causes change of motion? A wagon is a useful tool for moving a large load around more easily. Suppose you have a wagon sitting motionless with a load of watermelons in it. To take the watermelons with you, you will need to put the wagon into motion. How can you do that? You have two options. You can get behind the wagon and push it, or you can get in front of the wagon and pull it. The wagon will not move by itself. The wagon will move only if a force acts on it. Pushes and pulls are forces. Red arrows show force. Forces make things move. Blue arrows show direction of motion. Pushes and pulls are forces. Red arrows. Forces make things move. Blue arrows. If you apply a force to get the wagon moving, it will keep rolling. Oops, you don't want the moving wagon to crash into something. How can you stop it? It takes force to change the motion of a moving object. Again, you have two options. You can get in front of the wagon and apply a pushing force to slow or stop its motion, A. Or you can get behind the wagon, grab onto it, and apply a pulling force to slow its motion, B. To bring a moving object to a stop, you need to apply a force in the opposite direction of the motion. To change the motion of an object, a force is needed. If the rolling wagon of watermelons is moving too slowly, how can you make it move a little faster? You can use more force. If you get behind the wagon and give it another push, the wagon will move faster. The wagon will move faster if you get in front of it and give it another pull, too. More force in the same direction will make the wagon move faster. If the wagon starts moving too fast, you can use a push or a pull to slow it down. Force can be used to change the speed of a moving object. If the wagon starts to roll to one side, how can you make it roll straight again? You need to apply a force. But this time, you need to apply a force to the side of the wagon in order to change its direction of motion. Any change of motion of an object, such as starting, stopping, change of speed, or change of direction, requires a force.
So at this time, pause the video, look on your sheet, and answer any questions that you need to answer for what causes change of motion. When you're ready, hit the play button to go on to the next section called gravity.
Gravity. Think about a ball resting motionless on a table. A gentle push on the ball will put it into motion. The ball will roll across the table. What will happen when the ball comes to the edge of the table? The ball will roll off the edge and fall to the ground. The ball's motion changes when it rolls off the edge of the table. It moves in a different direction and starts to move faster. What causes this change of motion? That's right, force. What force makes the ball move toward the ground? The force that makes the ball fall to the ground is gravity. Gravity is a pulling force between two objects, and it draws them toward each other. The bigger the objects, the stronger the gravitational force between them. Earth is a huge object, so it pulls strongly on all other objects. It is the force of gravity that pulls objects to Earth's center. When you toss a basketball through a hoop, gravity pulls the ball to the ground. If you return the ball to the flat tabletop, it will again rest there motionless. Why doesn't the ball fall to the ground? The ball doesn't move because the forces acting on it are balanced. There are two forces. First, the table is pushing upward on the ball. Second, gravity is pulling the ball downward toward Earth's center. When two equal forces act on an object in opposite directions, the forces are balanced. When the forces acting on an object are balanced, the object's motion does not change. But what happens if you tip the table? The ball starts to roll down the table. For the ball to start moving, a force must act on the ball. Tipping the table unbalances the forces. The forces are no longer opposite and equal. Gravity pulls the ball downhill toward Earth's center. The round ball rolls across the table, over the edge, and down to the ground. When you're on a slide, can you feel the moment when the forces become unbalanced and gravity pulls you down?
So at this point, you're done with the video. Talk to your partner, look in the textbook, and answer the questions on gravity. Make sure you draw the pictures accurately and describe the motion of the spheres.